Here we go. I think it's recording. Is it recording? Yeah. Okay. So this is introductory algebra second class, September 1st. It's me and Carissa in the classroom, and we decided to do it on Zoom. Because it actually we're so good to you, because we decided to do it on Zoom so you can see better. Okay. So today, oopsie, let's pray. Now pray. Father God, thank you so much for this day. Thank you for Carissa. Thank you for all the students who are not here, and help us to learn this important lesson on factoring. In Jesus' name, amen. Yeah. So Carissa, you don't have another screen. You just have watch and look at the screen, right? You're not doing two things at the same time, because you like to do that. Okay. So first, what we're going to do. Okay, we're skipping all this part. So we're going to. So factoring, what is factoring? I'm going to explain what is factoring in a second. Okay, factoring. So what is factoring? Where is the annotation? Okay, here is the definition. So let's take the number 100, right? So I want to write 100, I want to factorize 100. So what would be the factorization of 100? Example of factorization would be, let's say 2 times 50. Right now I just factor the 100, or another way to factorize 100 would be 4 times 25, and so on. There is something called prime factorization. Do you know, Carissa, what is prime factorization? Do you remember what this was? Yeah, the bare minimum, which is the prime factors. You cannot factor more. So what is the prime factorization of 100? Would be what? No, but we want it to the best. So to do the prime factorization, we need to do something called the tree. Remember the tree? So I'm writing it on the screen now. So okay. Can you write on the screen? Click on annotate. Do you have touch screen? Do you have mouse? Kind of. Okay, see if you can write. Click on annotate. See, like somewhere in the options, in the option bar, you have annotate. Let me see. Hold on. I'll come over. Okay, so this part. You should be able to annotate, but I remember Mariana Kruger. Wow. Wow. Zoom for participation, but you can tell me what it is since you're here. Okay. So we're going to do the trick, Carissa. So let's say we can do like 2 times 50. You can do it like 2 times 25. This is 5 times 5, right? So you cannot go anymore. So since you cannot go anymore, these are the prime factors: 2, 2, 5, and 5. So you can write your 100 as 2 times 2 times 5 times 5. And this would be the prime factorization of 100. The same thing you can do if you have polynomial, or let's start with monomial. Okay, let's see. Do you remember what monomial was? Let's say 10x cubed. This is monomial. Right, Carissa? Okay. So how we can factor this? You can do 2 times 5 times x times x times x. All right. This is the prime factorization of the screen. Actually, okay, so if you want, you can even because I see you there. If you want, you can even turn off your picture. Is fine. You know, if it's distracting you to have to be on the screen. Yeah. So let's see how we can do this if we have polynomial. Let's say 10x cubed plus 5x squared. Okay. So I want to factor this. So what do you have any suggestions, Carissa, how we can factor this, make it into multiplication? Yeah, so what can we factor out here? Look at the numbers. Which number can you factor out? 5. Okay, how about the x's? How many x's can you factor out? X squared. Perfect. Here we go. So I put the what am I going to have in the parentheses left? That's correct. Plus, what's the other part? Wow, no, we took the 5x squared once. 1, that's correct. We need to have 1. This is a good example. We need to have 1 because the 1 is going to save the spot technically for the, you know, the second term. If we don't write 1, then when you go back and multiply out, right, here on the screen, you're not going to get the second term, right? So let's move on to the next page. I think this is better for the students. Okay, let's move on to here. Go. Okay. Okay, so let's look at so this example when you have a common factor, right? In the previous example, 5 was the common factor. So let's look here. You have A, B, and AC, right here. So the common, what is the common factor in there, Carissa? In AB plus AC. That's right. A is the common factor. Yeah. Okay. So, come on, what's next? Now what? Okay. Why not moving? Go next. Page down. What? Oh, because I'm what? Okay, doc. Still not moving. Come on, move. Oh, takes time. The internet is not very good. We can blame it on the people in the next room who are having class. Okay, and their own internet. So here is example of a trinomial. Has 3 terms, and you can factor out the common factor, right? The greatest. So what we're looking for is the greatest common factor. What is first? We're going to start with the numbers first. Which number do all those have in common? Carissa, which one is it? 4. It's obvious, but let's do 4. It's right there. So then you look at the x's. So how many x's do they have in common? 1. That's right, because they all need to have it. So this one has only 1. So this one is limiting us. We cannot factor more than 1x because of this one. So the whole factoring would be, and then it would be x squared plus 3x minus 4. It's written right there. Okay. So for any of you watching this video, if this is not enough explanation, you can go on YouTube and just Google factoring a common factor, and you're going to get many more videos. Okay. So I'm going to, oh yes, what is it?
Would you factor out the x squared plus 3, or would that be a different lesson?
Oh no, it's a different lesson, but very good. You're remembering. It's the future lesson. But the problem is, it doesn't want to go further. Keep going. The page doesn't want to. Oops. Okay, takes time. What is going on? Okay, here you go. Carissa, you tell me. Factor. What should we factor out? 3. 3. Okay, she said 3. Hold on. Okay, dokie. Here we go. Good job. So let's move on. This is very powerful computer. I don't know why it does not like doing this. Okay. Factor each term. Yes, I need to. Okay, here we go. Oh, Carissa, challenge. Next one.
I do want to use paper.
Yeah, you can use paper. Too bad you cannot write on the screen. It's a lot of fun. But your computer is weird, like the one Mariana has. I believe doesn't allow. You can do it on your phone, but next time. Oops. Got it? So what is the number? Got it. 2. Okay, let's see. Is there anything possible? 2, 4 times 7. Can we do 4? Okay, you got 2. Let's do the 2. Are you staying with the 2? No. Seven would not. Let's see. 28 and 30. Let's do the 3. 28 is 4 times 7, right? And 2 times 2. Let's do the 32. 32 is what? 4 times 8, right? So from here you can see that they have 4 in common, right? You see? One is 4 times 7, the other is 4 times 8. See those numbers? So then this means that you can factor out a 4. They all have 4 as the greatest common factor. So we're going to go after 4. Okay, so it's going to be 4. So if you do, how about the x's? How many? 3? Okay. X cubed. So 4 times 7 was 28, so it's going to be 7. And how many x's, Carissa? 3, that's correct. So x3 plus, what number is it? 4 times 8. How many x's? That's correct. Okay. I want to explain in case the new students, which I don't know what they know or what they don't know, because they have not taken the knowledge check. Okay, so guys, the new students, you have to go and take the initial knowledge check on Alex. I see that you signed up, but you have to take the knowledge check because from today, you have to start doing homework on Alex. Okay, but just for the new students, why is x cubed and x cubed right here? The reason is because you have, if you multiply x cubed times x cubed, the rules of exponents says that this the exponents would add. So this would be x to the power of 6. All right. So that's why you got x cubed split. Okay. Okay, moving on. Okay, next one. Ooh, Carissa, your turn again. Factor out. 3, okay, you're right. 3 is the number. Come, let me write 3. There's 3, and then what? That's correct. So what's left in the parentheses? 4, right?
4x minus 7x plus
3 times 8, that's correct. Okay, 8. 8. That's it. Because the x cubed already, we took it in front. Hey, very good. Good, good. Moving on. Oh, wow. Okay, there is another one for you. 9a squared b3. Okay, and what's left? Is that's correct. Plus 2. I want to say 2. Okay. Next. So, whoa, another one. Okay, Carissa. Go. Okay. 2. Okay, 2. Okay, so we can do it with 2. Okay, let's do it this way. 2x. Okay, then what's left in the parentheses? Plus w. Wait, plus 4w. We need a 4. 4. 2 times 4 is 8. 4w minus 6 times 2 is 12. 6, that's correct. Okay, this is one way. Another way, because we don't like, but this depends on what the context, what you're trying to do. But in general, we don't like to see this minus right here. It kind of ruins the flow of the expression. So another way to do this is to factor minus 2x. Right? It's another way to do it, but again, it depends on what you are trying to do. So there is no, like, it's not set in stone that you need to minus the 2, right? To factor out minus 2. Okay, so if you do this, what is going to happen? So it's still y is going to be positive, right? Because when you multiply, okay, hey, we forgot the, oh, yeah. Wait, Chris, we forgot the 2 right here. Oh, wait, why didn't you factor 4? What are we doing? Yeah, okay. Plus we forgot, I forgot here I forgot to write the 2 anyway. So if you factor 4, okay, so let's do this one. Okay, we do the red one correct. Okay, so minus 2x. So we're going to have 2y left, right? 2y. Then for the next one, I'm going to have 4w. So what is going to be the sign in front of 4w, Carissa? A negative. That's correct. Why is it negative? No, because when you multiply it, hold on. Because if you go back and multiply, see right here, this negative times this negative is going to be positive 8. Josh, we are right now on live Zoom. What is it? Phone? Why? Here we go. This is Joshua Pet. All right, go. This is going to be very entertaining video, I think. Okay. Okay, minus 4. Because when you multiply them back, you should get the positive 8 right there, right? Okay. So then the next, what you're doing, the minus 12, so it's going to be positive. The way we roll it is 6. Okay. So this is because we did not see that you can factor out a 4, right? Okay, let me just erase. Where is there is eraser? So look at, okay, let's see. Okay, so look at the expression. Look at the second one. Let's see, where is the shading? Let's take a blue shading. Okay, look at this expression. See this one, the one I just highlighted blue? If you look there, they also have a common factor. The common factor is 2. So once you are at this situation, when there is common factor in each term, you have to factor out this factor as well. So if we continue doing this, it's going to be minus 2x. So like we need to factor out a 2 from there, like so times 2, then y minus 2w plus 3. Okay. And then when you multiply the minus 2 and 2, you're going to get minus 4x y minus 2w plus 3. So this is the final answer for this problem. Again, depending on the context, you can factor out positive number or you can factor out a negative. The reason to factor the negative is so we can get rid of this negative inside the parentheses here, which kind of doesn't look so nice. Okay. Next. The good thing about Zoom is that you can stop it and look at it, so I don't have to do it slow. So factoring by grouping. This is the second part of lesson 5.1. We're still at lesson 5.1. And if you have the book, this is on page 323. Okay, I just write down page 323 in the book. Okay. So sometimes expressions can look like that, right? Like this. So, Carissa, what do they have in common? Look at this one, this expression I kind of highlighted here. What do they have in common as a factor? That's right, x plus 2. Even though it looks weird, it's kind of x plus 2 is not just 2 or 4 or x. This one is the same, so you can factor it out. So what happens if you factor it out? It's going to be x plus 2 and then x squared plus 3. Right? So this is the factoring of this. Okay. Let's see if we can do another one like this. Let's see what's next. Oops. Okay. Here it is. Okay, so before should we do another one? No, Carissa got it. Okay, so we're going to jump right into the next part, which is called factoring by grouping. I really think that this should be at another place in the book, not right now, because I don't think you're ready to do it. But we'll do it, and then in another chapter, like chapter 5.6 or 7, we're going to practice in details again. Okay, it's called factoring by grouping. So what is factoring by grouping? Okay, to factor by grouping, you need to have 4 terms. Your polynomial needs to have 4 terms. You see how there are 4? 1, 2, 3, 4. Okay. So what you do, Carissa, do you remember how to do it? So what do you do? Okay, let me write it right here for us. 3x cubed. I think it's Carissa is going to tell us what to do. Okay. Oh, the first one is the hard one, but okay, okay. So what do we do? Yep.
After that, just factor each one out the way you want to
Okay, so let's see. Okay. Yeah, if they need factoring. So let's go ahead. Okay, so what can you factor from the first group? That's why it's called grouping, because you're making 2 groups. Doesn't matter who is who, just take the first 2 and the last 2. Okay, so what do we factor from the first? 3x squared. Sounds like a good choice. So we have x plus 3, right? Then the next one is x plus 3. So what you can factor, I mean, there is nothing you can factor, but you can think if this helps you can factor a 1. You can put a 1 right there, right? Okay, so your goal with when you factor by grouping is to have in the first and the second term to have a common factor, right? Which is the same, and we got it. Let's make it green, and let's play here with the, oops, whoa, let's highlight it like here, see? This is the common factor. So we're going to factor this thing out. Oops. With some different color like red. Okay, so I'm going to do x plus 3. And what's left in the parentheses is 3x squared plus 1. Okay, we factored it. This was factored by grouping. So I'm going to clear it, and we're going to do the second one. Okay, Carissa, why is not clearing this red stuff? What happened? Why is not clearing this? Did they permanently wrote it on the screen or what? Okay, well, it's not clear. Okay, so Carissa, B, 2 groups, How about, tell me what to do. Wait, I'm getting, wait, what is this? Okay, security, mute. Oh, I'm under the, oh, anyway, making it red again. Okay. What should we factor? Teresa from the first group. Talking 3x. So what's left? You tell me 3.
3x to the power of 3 plus 2.
Good. So now the second one, what should we factor? What do you think? 27 and 18, what do they have in common? I mean, what is the greatest common factor? It is 9, it is 9, it is 9. Okay, okay. 9, and how many x's? Good job. Okay, so I factored 9. So one thing I want to point out, let's point it out in green. See this minus? When there is minus, you need to leave the minus there. Okay, so the minus would stay in between the two groups. And once you finish your problem, the first term would be 3x, 9 times 3 x cubed. But then the second sign, you need to flip the sign. It needs to be plus. And the reason is because if you go back and multiply, let's make it green, right? If you do minus 3 times, minus 9 times 3 is minus 27. But if you do minus 9 times positive 2, this will end up being negative 18, right? Negative 18. Because if you would leave this a negative right here, then if you multiply negative 9, negative 2 is going to be positive 18, so it's going to not be the same as the previous one. Okay, so it is negative go. Okay, so now the last step you take, and your goal is to have like to have those two terms to be exactly the same. So if you don't change the sign on the 2, they won't be the same. Okay, so then 3x cubed plus 2 in parentheses 3x minus 9. Yeah, we did it. All right. Okay, good job, Carissa. Let's see. Okay, here is the solution. What happened with the plus? Oh, this is the first problem. Okay. Okay. Here you go. Minus 9, negative 9. Okay. Tips for factoring. Okay. Ooh, look, black screen. Okay. So this was chapter 5.1. If we look in the syllabus, we need to do chapter chapter 5.2 as well today, right? It's 5.1 and 5.2, and we have plenty of time. It's surprising. Okay, so we're going to get the next PowerPoint. We're going to close this PowerPoint. 5.1. Want to keep your ink annotations? No. Right? No. Definitely don't want to keep them. Okay. But this was a good thing. I guess I can keep the PowerPoint. Okay, so then we open the other PowerPoint, which is chapter 5.2. Okay. It looks very nice on the screen. Oh, okay. So this is very important. Okay, the previous was very important, 5.1. This is super important too. It's easy, but make sure you get it. Okay, and there are many ways to do it. I'll just do it one way. If you want, feel free to go on internet, Google factoring trinomials of the type the type, and then you can use any other method. Okay. So let's see. Oops. Let's see what's on the next page. Okay, before we do this, let's do something. Okay. Let's get it from the book. Imagine you have to multiply. So Carissa is going to be multiplying for us. So Carissa, you're the star of this performance. You are a star. Nothing you can. Why? It's so fun to be a star. Okay. X, x plus 2 and x plus 5. I guess I like, I don't know that I would try to be a star, but I'm always like, want to be in front doing stuff. So when somebody doesn't, I'm like, no, you should. But people different. Okay, Carissa, let's multiply this. FOIL. FOIL this and tell me what you're going to get. Okay, blue. Okay, FOIL. Here we go, FOIL.
X squared plus 7x.
Oh, x squared, let's get x squared plus 7x plus 10. Okay, actually, I'll do this. It's going to be x squared plus just 5x plus 2x plus 10, right? Plus 10 right here. Plus 2 times 5. Hold on, let me write this 2 times 5. Okay, but this is what Carissa got. X squared plus 7x plus 10, right? Because this is right here 7x. And this is 10. The reason I wrote it like this is so I can see something. Notice that the middle term is going to be sum of the 5 and the 2. Right. Yeah, Carissa knows this, but I'm just explaining for the online audience here. And the last term is the multiplication of 5 and 2, the product of 5 and 2. Right? Oh, Carissa what disappeared. Now she's back. So now we have an echo. What did you do, Carissa? Did you do something? No. Now there is no echo. Ah, okay. Now there is an echo. Did you do something?
Yeah, I asked if I wanted to refresh it.
Ah. Okay. Because now we have an echo.
We have a what now?
Echo.
What do you think? That's what I've been hearing in my headphone this whole time.
What is it?
I've been hearing an echo in my headphone this whole time. You speak, a few seconds later, I hear it in my headphone.
Ah, okay, okay. Turn off the headphones. Turn off the headphones.
I don't know what I'm doing. I don't know what I'm doing.
Let's see now. There is still echo. No, the headphones were the problem. Whew. Okay. Yeah. Okay. No, you're good. So now it's okay. This was, as I said, this will be very entertaining video. Okay.
Sorry.
Good. Okay, so I have an echo too. Maybe it wasn't the headphones. What the heck? No, Carissa.
I'm working on it.
Mute your microphone. Find the mute. Hold on, I'll mute you. Got it muted? Ah, you're muted now. Good. Okay. You're good. Okay. So we muted it. Okay, so we're back to the problem, right? So what you do? Okay, so we learned this. So let's go to okay, factoring. So we're looking at this problem, right? So let's do the reverse of what we did earlier, the reverse of multiplication. So what you're thinking here, and then I know Carissa knows this, I'm just explaining for the online audience. What you're going to do, you want to factor this, make this into multiplication, this polynomial, right? And your thought process should be, so which two numbers multiplied, let's say A times B, right? Which numbers multiplied would give you 12, and when you add them together, let's say the numbers are A and B, would give you 7. See this? 12 and 7. So Carissa, what are the numbers which multiply to 12 and when you add them together give you 7? 3 and 4 is what Carissa said. Okay. And then, so those numbers you're going to put right here. 3 and 4. Carissa found that A is equals 3, B equals 4. It doesn't matter which one is A, which one is B. Just one of them is 3, the other is 4, right? Also, the order doesn't matter where you put the 4 and the 3 right here. Yes. Yeah, later, but right now it doesn't. The reason it doesn't is because if you look here, there is X, you know, there is nothing in front of the X. So those two X's are identical, right? So it doesn't matter, but later it does. You're very right. Okay, so let's do another problem. So here is the problem. Oh. So here, think of foil in reverse. Oops, wow, what did it do? Whoa, okay. So think of which, the product is 12, the sum is 7. What you can do in the book, you have a lot of examples like that. If I hope that you can figure it out like just looking at the numbers. They're not so, the numbers are not very hard. But if you cannot, you can write all the pairs of the factors of 12, right? All the factors of 12, you can write them right here. And then you can add them together to see if they add up to be 7, right? Because you want to get 7. Feel free to do that. Okay. Next is, oh look, okay. Is it the same problem? Yes. You can make this problem very complicated. Okay, at the end, if you want to check, oops. So if you're on the test, or if you want to make sure you got it right, usually you get it right, but sometimes you don't. So if you want to check, you need to take, the factored form of the polynomial and need to multiply it out. You can just FOIL it again and see if you're going to get your original polynomial. Oops, the other way. Here we go. You got it. Easy peasy, lemon squeezy. Woo. Okay. So what is this? We're just going to take example and do this. Okay. The next problem is, let's try to do this first problem right here. Let me highlight it in green. Okay, so let's do this one. Oops. See, the difference with the previous one is that there is minus instead of plus right there. You see, minus instead of plus. See it, Carissa? Minus instead of plus. So what's the difference? Oh, this is a different problem actually. Okay. So you're asking which two, so we're looking at this problem. The numbers you're looking for needs to multiply to give you a positive 10. So A times B should give you positive 10. But when you add them together, right, they should give you a negative 7. So Carissa, what does the negative 7 tells you about the numbers? Yes. Okay. So so you know that one of them needs to be negative at least, right? If not both. So then when you look at the 10, what does this tells you about the numbers? Their sign. Yes, because the only way to get a positive by multiplying negative numbers is if both of them are negative, right? So this is very important. Good job. Hey. Okay. Factor. Okay. So, Carissa, which two numbers multiply to give you positive 15, and when you add them together, give you negative 8? Okay, Carissa says negative 3, negative 5. So let's write the answer. So the answer will be, you can set up your answer actually with the parentheses and the variable, in this case is y. This way, if you set up the problem before you even do any actual work, you feel like you're ahead of the game because you know what you're missing, just two items right there. Okay, so Carissa said negative 3 and negative 5, and she is correct. Yes. Okay. Solution, here we go. Those PowerPoints, by the way, are available on Populi under lessons. If somebody wants to go through the PowerPoints, and the PowerPoints are from the book. So you can either use the PowerPoints, you can use the book. They're the same examples. Okay, so now when the last term is negative, let's just, okay, so let's look at this example. I see how not only the first term is negative, but then the second is negative. It's like, whoa, those negatives. Okay. Whew. So, which two numbers multiplied give you negative 21? So A times B is negative 21, but then when you add them together, you get a negative 4. Carissa, what does the A times B tells you about the numbers? The first, A times B is negative 21. What does it tell you about the sign of the numbers? Like, how can you multiply two numbers and get a negative number? What does the sign of each number needs to be? That's right. They need to have opposite signs. This is what we are after. Okay. So Carissa found out that, okay, put this, where is the minus right here? That one of the numbers is positive, the other is negative. So then we're going to get negative 4. So this means that the sign of the larger number or the bigger number is going to be a negative to get a negative result. So let's think. Okay, let me erase this. So which two numbers multiply to 21 first? 3 and 7, or 1 and 21, but it's kind of far-fetched. Okay, so 3 and 7. One is positive, the other is negative. So which needs to be positive, which needs to be negative to get minus 4? Yep, so it's going to be minus 7 plus 3 is minus 4, right? Because if you put the negative on the 3, it's going to be minus 3 plus 7, which is positive 4. So this would not going to work. Think no. Okay. So the numbers are negative 7 and positive 3. Yes. Okay. Let's go next. Is this the same problem? This is different. Okay. So Carissa, okay. Yeah. You have to work today, but then you can rest. Okay. So tell me, which numbers multiply to give you negative 24 and added together give you 5? Negative 5. What is it? 4 and 6? No, because 6 times 4, you're right. Is oh, that's right. And I said 4 and 6, which is 24, but when you add them or subtract them, you're not going to get 5, right? So what else makes 24? 2 and 12, yeah. When you add or subtract, one get 5. So let's do. There's one more. Gives you 24. Which one is it? 3 and 8. 3 times 8. Okay. And now this one is tough because the 3 times 8 always sneaks like under. Nobody thinks about it because 6 times 4 is 24, so people forget about 3 times 8. Okay. Yeah, but it's 18, and no, 3 and 6 is 18. 3 times 6 is 18. Okay, so you got it. So which needs to be positive and which needs to be negative? Okay, so it's going to be 3 minus 8 equals minus 5. So the 8 is negative, 3 is positive. So the factoring is going to be x. So we have positive 3 and negative 8. So again, doesn't matter in this case, doesn't matter where you put the 3 and the 8, as long as they have the correct sign. Okay. In the next chapter would matter though. So it's clear. Is it clear? Very interesting. Sometimes it doesn't want to clear, freaks out. Okay, I cannot clear it. I want to clear the drawings. Guess this computer doesn't like Zoom today for some reason, and PowerPoint. Okay. Here is the problem. Okay, almost there. Next one. Carissa, look at the problem. Let's see. Okay, so is there something we need to do first before we continue? Yeah, but okay, so what needs to, like, which two numbers multiply gives you, like, which number are you looking at to get the multiplication? 4 or 32? That's right. So what you need to do, the way I was getting into the fact that let's arrange them into, first to arrange it so it looks, so we have the exponents, the powers of t in descending order. So it's going to be square 40 minus 32. No, this is the same problem. No, it wouldn't. But just because we're all used to get the last number and multiply, right? And if you don't think about it, you just look at the 4 and do it. If you don't pay attention to the t, you got it. But let's just try to rewrite it. Here, they even recommend it right here on the PowerPoint. Just rewrite it. Just make it a practice. You want to arrange, like, some people when they study, they want to arrange their desks to be nice so they are not distracted. The same way is nice to arrange your equation. Okay, so now which numbers multiply to give you 32? 8 and 4. 8 and 4 would work, right? Yes, you're correct. 8 and 4. Which one is positive? Which one is negative? 8. That's correct, because the addition is a positive, right? So it's going to be positive 8 and negative 4. Yay! Good guy. Next one. Here are all the pairs, the possible factors, and there's some. Okay. Factor. Ooh, more. How many more? Okay. I think this is one of the last ones. Okay. This one is a hard one. Do you remember, Carissa, how to do the ones which had like two variables squared? Like, see how it has a squared and b squared? Yeah.
I remember how it opens, it's just I don't remember exactly how it's going.
Yeah. What we need to do, so we need to pick, okay, in this case, we need to pick either A or B to be our variable. The other one we're going to ignore, right? So let's go after A. Hold on, let me erase those. Okay, so we're going to go after A to be our main variable. Oops. A, and there is no A, right? Let's say I'm going to underline the 30 right here, okay? And B, we're going to ignore the B. The B is still there, which is going to ignore it. As long as you make sure there is symmetric, you have a B square, A square, and then you have A and B in the middle, right? As long as there is symmetry. So what you can do when you set up your problem, you can have here the A, here the A, but at the end you're going to have a B. You can just put the B right there, right? Because when you multiply the numbers, the last numbers, you're going to get B squared, right? So after you do this, look for the numbers. So which two numbers multiplied give you negative 30, and when you add them together give you 1, because here the number is positive 1. Let's think. Okay, 30. 30, how we can make 30? 1 times 30, which is no problem, obviously. 2 times 15. 3 times 10. Is there anything else? Oh, 4 times 5 times 6. Oh, 6 times 5. 6 times 5. So which one of those, when you add them together, because so they need to have opposite signs, right? Let's just put one negative, we put just one to be negative, right? So if you have -6, so let's need to add up to give +1 right here. So if you have -6 plus 5, what's that? Negative. So, but we want +1. So we're going, obviously the signs are +6 and -5. Oops. Right. Here we go. So it's +6 and -5. So I can get the 1. So I just found your numbers. So you can go back and fill them. One is so +6 plus 6 and -5 right here. Here we go. Let's check. So in this case, we're going to check if this is true. Going to erase all this nicely. Nicely erase this. Okay. 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 Let's erase. Okay. I mean, let's check. So I'm going to check. Let's write here. Check. Let's check. Okay. I'm going to multiply. So A. Let's make sure you get it. Okay. So it's going to be A squared minus 5AB plus 6AB minus 30B squared. Right. So then the last thing to do is to add like terms. So let me write here. We're adding like terms. We're going to add like terms. Okay, those two. And the result would be A squared plus AB minus 30B squared. Okay, so final reminder again. If you have A squared and B squared symmetrically distributed, like in this case, you have A squared, B squared, and then AB in the middle. What you can do, you choose one of the variables you want to keep. So we decided to go with the A squared. You could have went with the B squared and then rearrange the equation. But you decide to go after the A squared. And then when you set up your problem, you're going to have A in front and B at the end. Okay. Whew. Let's see, is there more? Oh, okay. I think it's the last one. Sometimes, even despite your best efforts, you won't be able to factor it. Some polynomials. Let's look at this one. For example, we have like which two numbers multiplied give you 7 and added together give you -1. The only factors of 7 are 7 and 1. You cannot make 7 any other way. So 7 and 1, no matter what you do, in Bulgaria we say you can boil it, you can bake it, but it's not going to give you -1. So, right, Carissa? So when this happens, your answer should be the polynomial is prime. They cannot be factored. So, and these are not very often, like these are rare occurrence. So don't write on the test prime every time when you cannot factor it, because the chances probably like maybe in 90% of the cases you can factor it on the test. So it's a rare, maybe even 95%. Okay. Okay, this is the last one. Okay, let's do this one. So Carissa, we want to factor this. So what are your thoughts? What should we do? That's correct. Carissa noticed something, which is that, the numbers are kind of big, the x's are cubed. We don't know, I did not show you how to do cubes, right? To factor cubed equations. So what you need to do first, you need to, let's make it in red. You need to factor out the greatest common factor, which is 2 from the numbers and x from the variables. So what you have left is x squared minus 12x. What is 72 divided by 2, Carissa? I think it's 36. Okay. Yeah. So now we factor the common factor, but we're not done because it says factor. When they say factor, they mean you need to factor it completely, right? You have to make sure everything is factored which you can. So the 2x would stay, 2x is out, but then you can actually factor out this polynomial right here. Let's make it. That's correct. Carissa got it. Which two numbers multiply to give you 36 positive? And when you add them together, gives you negative 12 minus 6, negative 6. Yeah, let's get rid. So x minus 6, minus 6. Ta-da. Another way to write this, and sometimes you can see it written like this, it will be 2x. And notice those terms are the same. So you can write 2x, x minus 6, you can square the whole thing. Right? It's another way to write it. And always, you see, always, this is always. If the problem looks complicated, for sure, like, something is, something is weird. They don't look so bad usually. So if there is a common factor, take it out. Okay. Hey. Okay, they found the common factors. Okay, how long is this chapter? One common factor. Okay, so these are the general rules. You can look at them later. This is what we went over. This is summary of it, how to factor. Okay, so for homework, I suggest do Alex. The new students, again, do the knowledge check and then start working. It's going to, what does it say? It says ready to learn. What does it say on Alex? On Alex, when you open your Alex, oops, no. Okay. On Alex, let's get it. When you open Alex, I don't have, my version is not like yours, but you're going to have on the left hand side the menu. What does it say? Was it learn? What's the top one, Carissa? Oh, she's going to look. One is review, the other is something and something. You can actually share your
learn, review, assignments, worksheet, calendar, Facebook reports, message center, experience management class.
Okay, let's see if you can share. See if you can share the screen. Okay, find a button. Yeah. Okay, so we're going to see your. If you share, if I share, okay, it's going to show up. Hopefully. Let's wait. It doesn't show yet. Okay, here it is. We need to go back. Go back in. You won't show your grade. Just show them the home screen. No, you're sharing. Then log in again because you logged out. Just log in again. I can see your screen. Just log in. Press the login. Here you go. Wait, the login for the Alex. This is open. Be almost done. This hasn't. Here's okay. Here we go. Man, I need a screenshot of that. How can I have a screenshot of that? Is there a screenshot version? I don't know. Okay. So you see how there is a. Where is the annotate? Where's my annotation? Oh, you're sharing, so I can. I need to be able to annotate. Oh. How is the annotating? of your options right now. Exit. Wow, I cannot annotate on her screen. Anyway, so there is learn, right? So click on learn, and then you're going to see all the things you can learn. And also don't click Carissa. And then on the right hand side, you can see she's working towards chapter 5. This is our next homework. We don't see it anymore, but it was like it tells you how many you have learned already and how many are left, and the due dates are there. So this is what you need to do. Okay, that's good. Yes, we can finish. So that's it. The end. Thank you, Carissa, for your participation. You were the star, so what can I do? You're okay. There we go.